Um, yeah, good. Hello, everybody. So here, just give me 1 second here, make sure everything is okay. Okay. So I'm recording this video to help you on lab 6. So first of all, let me tell you what we have done before and what we are gonna do differently in this lab. Okay. What we have done before, you learn it. How can you use power supplies? Okay. And the power supplies used before, it can give you, let me see if I can close this. Yeah. The power supplies used before, it can give you constant voltage. So this is the time, this is the voltage. If you use it like a voltage source, or in some labs, used it like a current source, so that you can generate, this is a constant current over the time. This is the current, okay? This is what we call power supplies. So here, what we have done so far, the input, we call it the input is DC. Okay, DC, as you see here, means it's a constant with the time. In this lab, you are gonna learn how can we use function generator. So I'm gonna tell you how function generator is different from power supplies. So both of them supplies, by the way, but this one for DC and this one for AC sources. So what do you mean by AC sources? For example, that's what we're going to see in some chapters. Sometimes the signal, if you have here time and you have here the voltage, sometimes the signal is AC, not DC, okay? And in this course, you will learn how can you analyze the circuits with AC sources. For example, if the very common one is actually sinusoidal, so you can see the signal is something like that. So here in this chapter, the first thing you are going to use for the first time is function generators. Function generator can generate different types of signals. So I'm going to show you. Yeah. So here, as you see in the lab here. Yeah. So here, if the function generator, as you see here, it can generate sine wave, okay, or it can generate a square wave, a triangle, tooth. So different types of signals can be generated for sure. Again, the very common one is sinusoidal, but again, this function can give you different signals, okay? So I want to give you more information about these signals. So in these signals, there are some parameters you need to be familiar with them. The first parameter you need to be familiar with is for sure is the period, or sometimes we call it interval or time interval. So here you can see the time. If you have a signal like this one, and this signal is periodic, okay? So this is the minimum pattern that's going to be repeated, okay? So the time, this time, we call it, this is the period, or this is the interval of this signal, okay? Now we have frequency. The frequency is 1/t. So this is very important to learn in this lab. If I give you the frequency, you can get the time here. If you have the time here for one interval, for sure this is identical. So that means if this is t, so next one also t. Next one is t, okay? Because it's just one pattern and you are repeating, or this pattern is repeated, okay? So anyway, so again, this is a relation between the, first you need to know what we mean by the period, okay? Number two, you need to know the relation between frequency and period. As you know, frequency is measured by hertz, Time for sure it is measured in seconds, okay? So this is the first parameter you need to know. The second parameter you need to know is actually if you have a signal like this one, how can we, or if you, from here to here, we call it this voltage here, we call it V maximum, or sometimes we call it VP, which means this is the peak voltage. Because as you see, the voltage is increasing to the peak, okay? And they are the same. So here, if this is also VM, the same value, you see what I'm saying? So sometimes if you have a sinusoidal signal, we use this parameter VP. So you need to know what we mean by VP or VM. So VP or VM is actually is the maximum. So actually VP or VM is actually the peak or maximum voltage. Okay. So for example, if I tell you VP equal to 1 volt, so that means this one is gonna go for 1 volt. So this is 1 volt, and this one also should be negative 1 volt. They are the same. There is another parameter we are using. We call it VPP, which means peak to peak, peak to peak. So what do you mean by peak to peak? It means, for example, if you have signal like this one, yeah, so we agree from here to here, that's V peak. But from here to here, it's actually VPP, peak to peak. Okay, so peak, we call it peak to peak. That means V peak should equal VPP divided by 2. That's true. So for example, if I tell you I have a signal and this signal VPP equal 4 volt, what it means? It means VP only equal 2 and 2. So 2 volts, that means if you have a signal this way, that means here should be 2 volt and here should be negative 2 volt. So from here, from the maximum value to the minimum value should be 4 volt. Okay. So now this is another parameter you need to know, VP, peak to peak. Okay. The other parameter also you need to know is what we call is the average value. Okay. So another parameter, we call it the average value. So to calculate the average value, it should be, for example, if you have a signal like this one here, signal something like that. Okay. This is the time t. So you need to calculate we need to use integration. So here the average value should equal to, let me go, sorry. Yeah. So the average value should equal to 1 over t in the integration from 0 to 2 pi. Yeah, 2 pi is here, okay. Or t, okay. In time, so let me get time from 0 to t, okay. V input dt, and this is for sure, this is V input of t, okay. So you need to integrate, okay, V input this way in order to get the average value, okay. It's easy to calculate the average error for this signal. You know why? Simply because, okay, let me tell you something here. What this value is, this is the area, right? Is the area under the curve, okay? Here, it's easy to calculate this part. This part here in this example equal to 0. You know why it's equal to 0? Simply because this area here is equal to this area, but this one is positive, this one is actually negative. That means if you have a signal, something is started from 0 this way, so what is the average value? You don't need to, if you want to use the formula, okay, you can use it, but you don't need. It's very clear. It is 0 because this area here equal to this area, and this one is positive, the other one is negative. Okay. Now, let's tell you something also related to this one. If you have a DC offset, this is one of the things you are going to do in this lab, DC offset. So what do you mean by DC offset? I'm going to tell you. If you have a signal like this one, so this signal is pure, it's a pure AC. So it only has AC. Okay, we agree this part here, if it is constant voltage, this part we call it DC. Sometimes we have a signal that has both of them together. So if I add these two together, what's gonna, for example, this one, for example, 3 volts. So what's gonna happen? This signal will be shifted up. So you can shift it up or down if you add DC. Okay. So what happens here? This is 3 volt, and then you can go up and down this way. Okay. So this is again what you can see here. The average value here is 3 volt. So that's what we call DC offset. This is something you can you can set in the function generator. Okay, do you want the offset to be 0? It's up to you. If you want the signal to start from 0, so you need to select the DC offset to be 0. If you want the signal shifted up or shifted down, yes, this is something you can control or something you can select in the function generator. Is that okay? Um, let me go back here. Yeah, the last thing I want to explain here, or the last parameters, actually you call it RMS value. Okay, so what is the meaning of RMS? First of all, RMS means root mean square. Okay, root mean square. Okay, I'm going to tell you simply what it means. Simply what it means is or first of all, how can you calculate it? So let's see here. Let's go to the, yeah. Yeah, so this is how you can calculate it, okay? Root mean square, okay? So here you can see this is the same formula for the formula you have here. It's the same formula for the average value, but it is for square, okay? So here, um, RMS, for this is for any signal should equal 1 over t, okay, integration from 0 to t, v square of tt, okay? And then, but here you take also square root of this one, okay? So, and then you take a square root. This is, you can calculate this value for any signal, or you call it RMS. Okay, what is the meaning of RMS? Why it's important? Simply, it means if you have a signal, something like that, for example, and I tell you RMS, for example, equal 1 volt. What it means? What is the meaning? I know how you know, how can you do the math? The math, you can use this formula here to calculate it, but what is the meaning of it? It's very simple. As we explained in one chapter, this is important when you calculate the power, okay? I'm going to tell you why, or what this means. It means if I connect this one to a load, a heater, or any other source, the power delivered from this sinusoidal signal equal to a power delivered from a DC source with the value of RMS. So again, what RMS means? RMS means the amount, if amount of power delivered from the sinusoidal signal equal to the same amount of power if we have a DC source with the value of RMS of this signal. That's why this value is important when we calculate power. Okay. But as you see here, if you just apply the formula, you can see here, in case of sine wave, yeah, in case of sine wave, the RMS value is 1 over square root of 2V maximum, okay? That for the triangle wave, it's again, you just apply the formula, okay? It's 1 over square root of 3 Vm. In case of square, it's VRMS equal to Vm, okay? For example, if I give you a signal like this one, 10, here as you see here, 10 sine omega t. If I give you a signal like this one, what is the maximum value? 10. Okay, so Vm is 10. So if I take 10 and I divide it by square root of 2, just to follow this formula here, this gives you the RMS value. Okay. So let me summarize what I said, guys. Okay, here. Okay, what I said, guys, here. Number one, this in these labs is that you are going to learn how can we use function generator. Function generator is similar to the power supply used before. It's a source. It's a source. However, the difference is that in case of power supply, it gives you DC values. DC. So this is the voltage, this is the time, DC. But in case of function generator, it is a source, but this one is going to give you a sinusoidal signal or AC signal. Okay. And as I told you, in one chapter or two chapters, you are going to learn how can you analyze circuits that have a EC. Everything we have done so far in this course is DC sources. Okay, so if you have here sinusoidal signal, something like that. So we need to be familiar with some parameters here. Why? Because when you set the power, when you set the function generator, you are going to set these parameters. Also, when you measure the signal, you are going to measure these ones as well. So what are these parameters here? Number one, you need to know what is the period. Number two, you need to know what is the frequency. Okay, so the period means if you have here signal something like that, if this is the time t, okay, so this is the period t, f should equal 1 over t. This one thing. The other thing is you need to know what is Vm or Vp, the peak value or maximum value. This is Vm. Okay, you need to know what is peak to peak. We call it peak to peak. Okay, so peak to peak should be from here to here. VPP. And because this part here is a positive peak equal to the negative peak, it's the same thing. Okay, so this one should be negative Vm. All what you have to do, if you have peak to peak divided by 2 to give you the peak value. Okay. One more thing you need to know, what is the average value? Okay. To calculate the average value, 1 over t integration 0 of t v of t dt. Okay, this gives you the average value. And again, the average value here, the average is 0, because again, you can see this part equal to this part. Okay, the area here equal to this area. So this is 0. And from here, it came what we call DC offset. DC offset means I can generate a signal like this one. Here in this case, the offset is 0. I can put offset positive. You can see. So now the signal here, it has two components, a DC value and also a AC value. Okay, or it can be negative. So you can put something negative and you can shift it up or down. You can shift it up or down by adding a DC component. Okay, so this is another thing. The last thing as I explained, which is actually the RMS value. Okay, the RMS value, as I told you, this is square root of 1 over t square 0 to t v square dt. Okay. And in case of sinusoidal, it is V maximum divided by square root of 2. This gives you the RMS value. Okay, you will understand why this is important. But the meaning of RMS value is, this is if I use this source, okay, to deliver power, okay, and if I use a DC source to deliver the same amount of power, how much is the DC value here? Should be this one, the RMS value. Okay. Let me see here. So this is the first part in this lab. First part in this lab is how can you generate signal, AC signal using function generator. The second part of this lab is how can you use oscilloscopes, or sometimes just we say to scope. Okay, oscilloscope or scope. This is a measurement device. Similar, you remember we used before DMM, okay, which is a digital multimeter. We used it like voltmeter, right, to measure voltage. That's what we did before. We used like ammeter to measure current. We use it like ammeter to measure ohm, right? That's what we did. This time, here we are gonna in this lab you are gonna use for the first time oscilloscope. It's also a measurement, okay? But this measurement, the way it works is, for example, and this is oscilloscope is only measuring voltage, okay, voltage, and it's very useful when you measure the sinusoidal signal. Okay, what's going to happen is that you are going to see there is a screen here, and there are here some squares, number of squares. Here also squares, and then you are going to see, for example, you are going to see your signal something. You are going to display the signal. Okay, so. Several things here. Number one, the oscilloscope is only used to measure voltage. If you want to measure current, you have to convert to voltage and then measure voltage. This is number one. Number two, oscilloscope is displaying the signal. Okay, so that's number two. Number three, I will tell you, although um, oscilloscope is very useful to measure AC signal. It is still okay to measure DC signals. Okay, so for example, if you want to measure a DC signal, you can use DMM as we did before. So you can use DMM as we did before, or you can use this. You can use the oscilloscope. So if you use the oscilloscope here, so what you are gonna see here, you are gonna see just a line this way. Okay, so because your signal is constant with the time, so this is the time, this is the voltage. Okay. Here's the same thing here. If I go back, this is the time and this is the voltage. Okay. The way you have to measure it for the time, you need to measure how many squares here. Okay. And it should be given to you for every square. For example, just 1 millisecond per square. Or we division, we call it division or square. Okay. So if I want to measure the time from here to here, you need to count how many squares you have. You need to count number of squares. Okay. And then after you count the number of squares, and already this should given to you on the scope, 1 millisecond or 2 milliseconds is something you can change in order to stretch or compress the signal. Okay. Same thing for the voltage. If you want to measure the voltage again, you need to measure here. You see how many squares here you have. Okay. And also it will be given to you, is, for example, 1 voltage per division. Okay, that means every division here is 1 voltage. So if I want to measure if I want to measure what is the peak, okay, so I can one voltage per division. Okay, guys. So again, let me summarize what I said. Uh, what I said, you are gonna learn a new measurement device in this lab. We call it oscilloscope. Okay. We already used DMM before to measure DC signals. And usually that's what we do. For DC signal, DMM is very good. But still you can use the oscilloscope also to measure DC signal. That's okay. But the point here is that in DC signal, I don't want to display the signal. I don't want to do, or it's not going to be very useful to draw the signal. You see what I'm saying? I just need to know the number, and DMM is giving me the number, but still you can use it if you want. So if you use it, what you're going to see, you're going to see just a straight line this way. That means this is the voltage, the time constant with the time. Okay. But if it is in case of AC signal, oscilloscope is going to be very useful. And again, you are going to displace a signal. After you displace a signal, you can measure the time, this is the time, or you can measure how many squares here to measure the voltage. Okay. Another very important thing here you will see in this lab, one of the parameters you need to select on the scope, do you need, let me see if I have space here. Yeah, okay. So you can make something DC coupling or AC coupling. Okay. So one of the things you need to select in the parameters of the scope, DC coupling or AC coupling. What is the difference between them? I'm going to tell you what is the difference. In DC coupling, okay, if the signal has two components, DC and AC, something like that. So this is the signal. This signal has two components, okay? This is the DC here, and this is the EC. You just edit the two signals together, okay? So in DC coupling, it's going to display both of them. In AC coupling, you are going to only display AC signals. That means if you have a signal like this one here, in DC, I will see it this way, but in AC, I will see it this way. Why? Because in AC coupling, it's gonna block any DC. So it's up to you. If you want to measure the signal as is, so just use DC coupling. If you want to use only the AC component, you can select AC coupling. Okay. Let me go to the lab to see if I'm missing something. Yeah. So here. Let me see here. Yeah, so here a function generator is a signal source capable of generating several waveforms. Okay, so it can be sinusoidal, it can be a triangle, it can be square, several signals. Also, this is one of the things you can select. Okay, so if I come here, also you need to select several parameters. Okay, these parameters like, yeah, so as I told you here, number one, what you need to select the waveform type. You want to select, you want to generate a signal that is sinusoidal or triangle or square. Number two, you need to select a frequency. Okay. What is the frequency? You need to select amplitude. Amplitude is the maximum value. Okay. Also, you need to select the DC offset. Okay, DC again, as I told you before, DC offset means you want to shift the signal up or down. Okay, so again, you have just a bunch of buttons here. That's what you should learn here. So you have different buttons here to do that. You can select the type of the signal, and you can select also all these parameters to generate a signal. After, so you can see here we have two outputs here. Okay. We have two outputs, this one and this one here. And then once you generate the signal, you have to hit the button output here to be able to see the signal. Okay. So this is the first one. The second one is the oscilloscope, as I told you. Okay. Yeah, as we see here, this oscilloscope is used to display signal, okay, as I told you. So you can see here we have 4 channels. That means you can display four signal at the same time, and you can see all of them. Okay, so you can generate the 4 signal and you can see all of them. You can see you have a channel 1, 2, 3. You can display only one. You can display more than one. Okay, this is the divisions or the squares I told you about. The x-axis is the time, y-axis is the voltage. Okay, all what you have to do, as I told you, for measurement, if you want to measure the time, you need to count how many squares or how many divisions, and then it is given to you how many or how much time per division. One millisecond per division, 2 millisecond per division, 1 microsecond, whatever it is. Same thing for y-axis, it's the voltage. Okay. Anyway, the other thing is just a speaker. So I'm gonna use a speaker. So here in this lab, so just normal speaker, so that after you generate AC signal, you can hear the sound. Okay, it's just so fun. So here, let me go through this lab quickly. In the first part of this lab here, you are gonna make a function generator, okay, and then you are gonna connect this function generator to the scope. Also, you are gonna connect it to DMM as we did before. Okay, so all of them they have to be parallel. So let me tell you here exactly what I mean here. What I mean, yeah, if this is a function FG function generator, for example, the function generator has 2 outputs this way. This is the DMM used before. Also, it has 2 outputs. So I'm going to connect them together here because I want to measure the output signal. Same thing here for the scope, for the oscilloscope. Also, I'm going to connect them in parallel this way. Okay. So let me tell you something here. If I generate a signal like this one, so here on the scope, I have to see the signal this way. But the interesting part, what you are going to see here in the DMM, what number you will see. Actually, and this you need to learn, here, DMM, they will give you RMS value. Okay, so let me make it easy. So if you want to measure a signal, okay, if you use the scope, you will see the signal. You will see everything. You will see the time, the peak value, everything. But in DMM, it's going to give you just a number. Okay. DMM here means a voltmeter, right? You are going to just get a number, and this number is actually the RMS value. And this is the purpose of the first part here in the lab. So here's just first part, just to make this connection. In the second part here in the lab, you need to generate the signal, and then you need to see. Here I'm asking you to just practice how to use the function generator to generate this signal. 1 kHz, 1 volt, peak to peak, 2 volts. So I give you some parameters, and then I want to generate this signal. And then once you generate the signal, DMM should give you this value, which is actually RMS value. 1 peak value divided by square root of 2. Okay. The second one here, same thing, but this time you are going to generate another triangle wave. Okay, again, this is also a parameter. You need to set the function generator to generate a triangle wave. Okay. Also, you will see here you have to use the formula for RMS just to make sure GMM is going to measure the RMS value. Okay. Next one here, I wanna compare the measurement for the function generator, because the function generator itself is gonna give you some frequency, it's gonna give you some parameters, and then you need to measure it on the scope. Just we wanna see if they are the same or there is a small difference between them or not. Okay, so yes, the function generator itself is gonna give you the output frequency. The scope is gonna give you the measured frequency. We wanna make sure both of them have the same accuracy. Okay. After that, you are going to connect the waveform to a speaker just to hear to some sound. This is interesting part. So now you can change the frequency and you can see how the sound will look like at small frequencies and how it looks like at high frequencies. The next part here, you need to add DC. As I told you, you can generate a signal with DC offset. So now the signal has both of them, DC and AC. Okay, and now you need to see what is the DMM DC voltage reading. So you need to know what voltage DMM here, and you need to justify for it what value measured here. Okay. Because keep in mind, DMM will give you just number. That's what you have used before all the time in previous labs. But the oscilloscope is gonna give you draw the circuit for you. The last part here is gonna, like, for example, because that's what we're gonna do in the future. If you have unknown signal, I don't know the frequency, I don't know the peak value, I don't know the signal. Yes, here this is a practice how can use the scope to do that. Okay, so again, the oscilloscope is a measurement device usually used for AC, but still you can use it for DC. Okay, thanks very much. Bye.